Okay, I decided to make a video in case you want to watch this tonight to have more time in class tomorrow, and if not, you can just watch it in class tomorrow. But the second derivative, to me, I use the second derivative to determine concavity and points of inflection, but there is something called the second derivative test that can help you find max and mins using the second derivative instead of the first derivative. And I'll kind of explain it to you. Okay, so here's the thing. This is going to be a lot of writing. So if x equals a is a critical number of f of x, remember a critical number is when the first derivative equals 0 or is undefined. That's a possible max or min. Right? So that means then f prime of a equals 0 or is undefined. Which makes it a possible max or min on f of x. Normally, the first derivative test, we find our critical points and then we do the number line and we check to see if it makes the first derivative positive or negative. You can still do that. But also, if the second derivative is easy to find, you can say that if the second derivative of your critical number, so if f double prime of a is greater than 0, then what does that mean? Well, when the second derivative is greater than 0, that means that f of x is concave up at x equals a. And if your graph is concave up and is a possible max or min, what is that? Well, then that means then x equals a is a relative minimum on f of x. And if f double prime of a is less than 0, then that means that f of x is concave down at x equals a. And think about what that looks like at a possible max or min. If it's concave down, then that means, I did do two thens, then x equals a is a relative max on f of x. These only work for critical points. Now here's why I don't use this test very often, but I still want to show it to you. If the second derivative of a equals 0, then the test fails, and we don't know. It probably means it's not a max or a min, right? It probably means it's an inflection point, but I always say go back to first derivative test. Usually it means that it doesn't do anything. It's where it doesn't change at all. It stays positive, positive, or negative, negative. Okay? So let's try a couple. So it says use the second derivative test to locate and classify all x values of relative extrema. So when it's a polynomial function, finding your derivatives are pretty easy. So the first derivative here is just 4x cubed minus 12x squared. If I want to find my critical points, remember that's when I set that equal to 0, so I could factor out a 4x squared, and that would leave me with what? X minus 3. So my critical numbers are x equals 0 and x equals 3. The first derivative test is when we draw the line and we would put 0 and 3, and we're going to check them. But we're going to use the second derivative test just so you can see how it works. Because if the second derivative is easy to find, I can just take the second derivative here, which would be 12x squared minus 24x. And I'm not going to set it equal to 0. I don't want to find the inflection points. I want to take these values and I want to plug them into the second derivative to determine if they're positive or negative. And notice on this one, if I plug 0 in there, I'm going to get 0, which is no good because that fails. But if I plug 3 in there, I'm going to get, what, 12 times 9 minus 24 times 3. 12 times 9 is 72. Is that true? I'm totally making that up. 12 times 9 is 108, I believe. And 24 times 3 is 20, 40, 60, 80 something. I don't know. It's positive. I'm going to say that. That's all that matters. That's a positive number. So since it's positive, that means it's concave up. And that means that there is a relative min at x equals 3. 72. That's the 72 I wanted. There you go. Anyway, it's positive. What about 0, right? I don't like to say, well, if it's 0, it must be nothing. I would go back over here and I would do the old-fashioned way. If I plugged in a negative number here, that would be positive and that would be negative. And if I plugged in 1, that would also be negative. So notice it's negative, negative. So this is nothing on my graph. So all I know is it's a relative min. Is that faster than the first derivative test? I don't know. But it's something that is one of the standards that we're supposed to teach. On a test, can you always go back and use the first derivative test? Yes. Are there times the second derivative might be easier? Yes. So just know that. So let's do this one. If I did the first derivative, what would I get? The derivative of cosine is negative sine, so that would be negative 2 sine of theta minus 1, because that would be like the derivative of x. If I set that equal to 0, look at this trig we got going on here. So I could add 1 over and divide by negative 2. Very nicely, they say we're only going between 0 and 2 pi. So the first step is to figure out what are my critical numbers. Where does sine equal negative 1/2? Well, sine is y, so it has to be down here in quadrant 3 and quadrant 4. Remember, sine is the y coordinate, so I think it's down here, right? This is square root of 3 over 2 1/2. So negative would be 7 pi 6 and 11 pi 6. And so we could plug those back in and we could just do the number line thing. We also could do the second derivative test. So if I did the second derivative, the derivative of sine is cosine, so that's just negative 2 cosine of theta, and the derivative of negative 1 is 0. So if I plug 7 pi 6 in there, I get negative 2 times the cosine of 7 pi 6. It really doesn't even matter if you know what that is or not, if you know if it's positive or negative. And think about 7 pi 6 is down here. Cosine is negative in quadrant 3, so a negative times a negative is a positive answer. So that means it's concave up. So I know that it's a relative minimum at theta equals 7 pi 6. And if I plug in 11 pi 6 into this, again, I don't even care if you know what it is. 11 pi 6 is over here in quadrant 4. Cosine is x, and it's positive over here. So a positive times a negative is a negative, which means if my second derivative is negative, it's concave down. So that means there's a relative max at theta equals 11 pi 6. Could you have got the same answers with the first derivative test? Yes. So if you watch this before class tomorrow, then in class you can ask questions and you can work on your homework the whole time.